What's going on, class? Welcome to our first revision video of the year. How exciting. Let's get it. Alright, so this one says quadrilateral EFGH is a scaled copy of quadrilateral ABCD. Select all of the true statements. And so, since we're told that these two quadrilaterals are scaled copies, what that tells us is that each corresponding segment has the same scale factor. And so that means I can multiply each segment by the same number. And so that means our scale factor, also known as SF, is going to be our copy over our original. And so our scale factor is just a unit rate, which both figures share. And so that means we're going to do our two corresponding sides, our copy over our original, so 12 over 6, which gives us a scale factor of 2. And so now we know we can multiply each corresponding side by 2. And so that means segment AD has a corresponding segment of EH. And so that means 8 times 2 gives us 16. We see here that BA measures 3, so its corresponding segment, FE, is going to be 3 times 2, which is 6. And then finally, CB has a corresponding segment of GF, and so that means 4 times 2 gives us 8. And so now we can use this information to select all of them that are true. So this is saying segment EF is twice as long as segment AB. So this is saying segment EF, which is located here, is twice as long as AB, which we can see that's true because 6 is 2 times larger than 3, so that means that this is true. Now, for the second one, segment CD is twice as long as segment FG. So this is saying segment CD is twice as long as segment GF or FG. And so segment FG can be seen here. And what we can see is that these are not corresponding sides. What's corresponding to FG is going to be segment CB. And so that means these are not corresponding. And so 6 times 2 is not 8, which means this is not it. They're not corresponding. Now this is saying the measure of angle HEF, so this angle here, is twice the measure of angle DAB, so this angle on the bottom. And so what's important to note is that scaled copies corresponding angle, so the corresponding angles are equal. And so that's an important concept, right? So the corresponding angles here are actually congruent. And so that means the measure of the two angles is equal. And so angle A and angle E are actually congruent. This just means that the measure of angle A and the measure of angle E is equal. So this one's not it either. Here it says the length of segment EH is 16 units. We can see EH here. We applied our scale factor of 2, so that makes this one true. And then our next one coming up, the area of EFGH is twice the area of ABCD. And so the concept here is that the areas, they have twice in the area. This is to throw you off because our scale factor is 2, right? What we need to remember is that to scale our area, we need to multiply our original area by our scale factor squared. So if we actually wanted this area, we would have to multiply it by our scale factor times itself. And so that means 2 to the second power, which is 2 times 2, which is just 4. Does not mean twice. And we're going to see that in question 3 as one of our possibilities, right? That doesn't mean twice. It's actually quadruple the area. Let's go to our next one. All right, let's go to our next question. Rectangle A measures 9 inches by 3 inches. Rectangle B is a scaled copy of rectangle A. So again, we have this concept of a scaled copy. That means each of these measurements need to have the same scale factor. And so again, a scale factor is just a ratio between corresponding sides. And so select all the measurements pairs that could be the dimensions of rectangle B. And so let's see this, right? And so again, our scale factor in this case would be equal to our copy over our original. And so if I want to do this one here, again, we had a calculator for this, right? 9 inches turns to 4 and 5/10 inches. So if I was to do this, right, I would need to put my copy on top. So my copy is on top, my original is on the bottom. And 4 and 5/10 divided by 9 just gives us 0 and 5/10. Let's do this for 1 and 5/10. And so now 1 and 5/10 turns over. So we go from 3 inches to 1 and 5/10 inches. And so if we were to do this, we would also get a scale factor of 1 and 1/2. So this means that our scale factors are equal. That's okay. And so again, this is a scale factor of 0 and 5/10. Let's look at our second one. Here we go from 9 inches to 8 inches and 3 inches to 2 inches. I saw actually a number of tests notice that both of these were subtracted by 1. This is an important skill. This is an important concept. Scale factor shares a multiplicative relationship. And so multiplicative just means that you need to multiply your scale factor. Since this is clearly subtracting by 1, right? 8 divided by 9 is not equal to 2 divided by 3. So this one is not possible. That leads us to our next one here, 10 inches by 4 inches. We can clearly see that it was added by 1. Again, scale factor shares a multiplicative relationship. Scale factor is just a ratio between rectangle A and rectangle B. Since both of these side lengths do not share the same scale factor, this is not a possible answer. Let's move on to our next one. So here we can see that we have two numbers that is not easy to see the relationship. So let's see if both of these end up having the same scale factor. So I do 13 and 5/10 inches over 9. And when we put this in our calculator, we end up getting 1 and 5/10. Next one, we have 4 and 5/10 over 3. And again, when we put this in our calculator, we get 1 and 5/10. Both of these have the same scale factor, so that means this is a possible answer as well. So our scale factor is 0 and 5/10. And then next one, this one a lot of y'all got, so really good job. You can see that 9 times 10 gives you 90, right? And then we do 3 times 10, that gives you 30. Both of these have the same scale factor, which means this is our final answer. And again, just to go over this one more time, a scale factor is a ratio between two sides. For instance, the ratio between 90 inches and 9 is 10 over 1. And 30 inches over 3 is also 10 over 1, which is why our scale factor here would be 10. All right, let's go to our next question. Here it says a scale drawing of a rectangle park is 5 inches by 7 inches long. The actual park is 280 yards long. What is the area of the actual park in square yards? And so what's important here is that we have 280 yards long, and we're told that the scale is 7 inches long. And so to conceptualize this, right, we can just draw kind of what the actual park would be and do 280 yards long. And just like our prior problems before, is we want to find our scale factor. So our scale factor, in this case, since we're going from a scaled image to an actual image, right, we want to do our actual over our scaled, right? Because the plans of the park, right, is what's going to influence the actual design. So our actual design depends on the scaled. And so here we have our 280 yards long over 7. inches. Why? Because these are the corresponding sides. And so if we were to put this in our calculator, our scale factor would just equal 40. And again, to apply our scale factor, we need to multiply, right? 7 times 40 gives us 240 yards. And so now that means we do times 40 to 5, and this gives us our 200 yards. And so 200 yards times 280 yards, when we put that in the calculator, we would have gotten 56,000 yards squared. Bam. And a quicker way I saw like 3 of us do this, which is really cool, is instead of doing all this, once you knew your scale factor was 40, right? 5 times 7 is 35 inches squared, which is why that's there to throw you off, right? You can do 35 inches squared times 40 to the second power. And so you end up getting 35 inches squared times our scale factor squared, which is just going to be 1600. And then when you do 3500 times 1600, you end up getting our 56,000 yards squared, which that's a pretty cool way. Shout out to some of y'all that ended up doing that on our test. All right, let's go to our next question. Here's a polygon. Draw a skilled polygon using a scale factor of 1/2. So many of y'all did so well on this one. I was so proud of you. And so here, first step is to get the segments, right? So you do corner to corner, 1, 2, 3, 4, 5, 6. So the length here is 6. Here, 1, 2, 3, 4, 5, 6, 7, 8. This was 8. We go to our next one, 1, 2, 3, 4. This is 4. Go again, 1, 2, 3, 4. This segment here is 4. Now, this is what actually tripped up a lot of us. A lot of us forgot this piece here. Again, it's just 1, 2. So this piece was 2. Then here was 1, 2, 3, 4. And now we apply our scale factor of 1/2. And 100% of us made this image smaller, which conceptually told us that if you're multiplying by something less than 1, your scaled image is going to get smaller. So good job on that, y'all. So here, what's half of 6? Well, half of 6 is 3. So I just go down 3. 1, 2, 3. What's half of 8? Well, half of 8 is 4. So I go to the right 4. 1, 2, 3. 1, 2, 3, 4. Bam. Get a side length of 4. Here, well, we do half of 4. What's half of 4? Well, 4 times 1/2 gives me 2. So this is 1, 2. Now again, what's half of 4? We just discovered that it's 2. So it's 1, 2. What's half of 2? Well, what's half of 2 is 1. So we go down 1. And then we go 2. What's half of 2? Well, what's half of 2 is 1. So bam. And that's how we did this one. A lot of y'all did really well. Where some of y'all messed up is you guys messed up here. I even saw a lot of us got half of 6 is 3, but end up with a bigger number because they messed up here and they just went with it. So overall, good job on this question. Let's move to the next. All right, again, we're working with scale factor, which in this case, again, our scale factor is a ratio, right? So we want to do our actual length divided by our scaled length. Well, what's our scale factor? Well, if we look up here, the scale of a map says that 4 centimeters represents 5 kilometers. And so this is a 4 cm to 5 km scale. And so that was the first step that we wanted to recognize. And then it asks, what is the distance in the map in centimeters representing an actual distance of 4 kilometers? And so it wants to know how many centimeters is 4 kilometers based off of our map. And so first step is put your scale factor in your T-chart first. And so our scale factor was 4 cm to 5 kilometers. And then it wants to know what 4 kilometers is. So I need to place that under our km section. And so now in order to get how many centimeters is I need to actually know my scale factor. And so here our actual length was 5. our scaled length of centimeters was 4. And so you could either put that in your calculator or get that it was 1 1/4, right? 4 goes into 5 one time. 5 minus 1 is 1. And so that's just 1 25/100 as a scale factor. Bam. Now, so what this means is 4 times 1 25/100 gives you 5. So that's 4 times 1 25/100. And so if I'm multiplying on a table from going left to right, going from right to left reverses that. And so in our calculator, we wanted to divide by 1 25/100. And so when you divided by 1 25/100, you would have gotten 3 2/10 centimeters. And so we would say the scaled amount is 3 2/10 centimeters. Going down on part B, it wasn't much different. Again, you want to start off with your scale factor, and so, or your scale. So here we have 4 cm to 5 kilometers. And then we're told, right, what is the actual number of kilometers as represented by 5 centimeters? So you want to put the 5 centimeters on the left under our centimeter section. And now apply your scale factor. Well, we already know our scale factors up here, which is 1 25/100. And so going from left to right, we multiply by 1 25/100. And so 5 times 1 25/100 just gives us 6 25/100 kilometers squared. Not squared, just kilometers. And so we can say the actual distance is 6 25/100 kilometers. And that's all for this one. All right, moving on to question 6. There are 2 different maps of Ohio. The distance from Cleveland to Cincinnati on the map is 40 centimeters, right? And so centimeters we know is going to be our scaled. The scale on the map is 1 centimeter to 50 kilometers. And it wants to know what is the distance from Cleveland to Cincy on the map in kilometers. Explain your reasoning. And so here we know our scale is given, which is 1 cm to 50 kilometers. And so there's 2 ways we can do this. Well, we know we're scaling to be 40 centimeters, right? And so our scale factor, right, is just 50, right? What do you multiply 1 by to get to 50? Well, just 50. And so that means we can do 4 times our scale factor of 50 to get 2,000 kilometers. And so we would say down here, the actual distance from Cleveland to Cincinnati is 2,000 kilometers. Now, don't end there. Remember, that's the answer. Tell me how you know this. I know this because I multiplied our scaled amount of 4 centimeters by our scale factor to get 2,000 kilometers. Notice here how I'm using vocab terms. That's a great way to explain your reasoning, and we couple that with our work on top. And again, we do this because on MCAS, right, most of the please explain is done through words, or if you're able to type out your work, that usually works as well. All right, we're moving on to our last question. Elena wants to make a scale drawing of her bedroom. her bedroom is a rectangle with a width of 5 inches and length of 3 inches. She decides on a scale of 1 inch to 5 feet. And so here we have her bedroom, which she measures to be 3 inches by 5 inches, and we have a scale of 1 inch to 5 feet. I want you to draw and label the actual dimensions of Elena's bedroom using a scale of 1 to 5 feet. And so again, to apply our scale factor, we want to multiply. And so here, 3 inches, right, we can multiply by our scale factor. And so here we have, right, our scale, which is 1 inch to 5 feet, which means 3 inches is going to be, right, what do you multiply 1 by to get to 5? Well, you multiply 1 by 5 to get to 5. And so that means you do 3 inches times 5 to get 15 feet. And so that means our length is going to be 15 feet. And so we can label that our length. And then our width is going to be doing the same process. So here our scale, we can say 1 inch to 5 feet, right? And then we have our scaled width to be 5 inches. What do I multiply 1 by to get to 5? Well, I multiply 1 by our scale factor, which is 5. So that means 5 times 5 gives us our 25 feet. And so our actual width is going to be 25 feet. Bam. And that's all they wanted you to do. So it's 25 feet by 15 feet. Let's move on to part B. Elena's bedroom door is 0 and 8/10 inches wide. How wide should the door be in her actual bedroom? Explain how you know. And so to do this mathematically again, we just issue our scale. So we have 1 inch to 5 feet. In this case, we're told that the bedroom door, right? So if I was to draw our door, we're told that the width is 0 and 8/10 inches. And so on the left, we do 0 and 8/10 inches, right? And now we apply our scale factor, right? Our scale factor is 1 inch to 5 feet. So you multiply 1 by 5 to get to 5 feet, which means we multiply 0 and 8/10 by 5. And so 0 and 8/10 times 5 just gives us 4 feet. And so that means the door, so I can put this here, the door is 4 feet wide. Well, how do you know this? I know this because I applied my scale factor to the scaled measurements of the door to get 4 feet. Bam. All right, let's go to part C. And so in part C, we have Elena's bed actually measures 10 feet wide by 6 feet long. It now wants to know what is the scaled measurements of her bed. And so if we were to draw her bed real quick, right, it's saying it's 6 feet long by 10 feet wide. And so we want to get the scaled measurements. These are the actual. And so when we were going from scaled to actual, we multiplied. Which means if I want to go from actual to scaled, we're reversing that. So that means we can either multiply by the reciprocal, or in this case, divide. And so here, right, I can divide 6 by 5. So if I was to just draw this out, we have feet on the left, inches on the right. I mean, reverse, inches on the left, feet on the right. Here we have 6 feet. I can divide 6 feet by 5 to get 1 2/10 inches. So that means that the length of the bed is 1 2/10 inches by the 10 feet divided by 5, which is just 2 inches. So that means it's 1 2/10 inches by 2 inches. And so these are the scaled measurements of the bed. And why is that the case? Is because we're going from actual to scaled. And so 6 divided by 5, or in this case, 6 times 1/5, right? Because multiplying by 1/5 is the same as dividing by 5. And so here's how we would end up getting 6/5, which is just equal to 1 2/10 inches. And that was our test.